Yeah, folks. So let me introduce our last keynote speaker, Don Wedges. I'll give a small introduction. Don is a dedicated member of Python community, currently serving as a chair of Python Software Foundation Board of Directors and a member of Organization for Ethical Source Advisory Board. She is the Director of Community and Developer Relationship at Anaconda, a leading provider of data science tools and open source distribution. Dawn is a vocal champion for open source software and a passionate advocate for building welcoming and inclusive space for developers and contributors. She brings her experience supporting Python developers tools at Microsoft and focus on nurturing the long standing community that supports Anaconda's open source core to the conference. Let's welcome her with a huge round of applause.
Hey everyone, I'm a bit short, so I'm going to be spending part-time behind the podium and a little bit of time out here. Also, it's the end of the day, and I appreciate seeing so many faces in the audience. This is going to be a little bit interactive. I'm going to ask for you to raise your hand and kind of do a back and forth with me. So if we could keep the energy up for the last part of the day, I would appreciate it. That would make the keynote go great. So, as we mentioned, my name is Dawn Wages, she, her pronouns. I came all the way from Philadelphia to PyCon, India, and it's been a fantastic occasion already. And this is my first time in India, so I really appreciate the warm welcome I've had. So, today we'll be talking about the Fellowship of the Stack. A scientific discovery with Python. And this is going to be a talk that's going to be really accessible to almost all of the audience, regardless of your expertise. But this talk actually started out, and I want to give a shout out to Purdue School of Advanced Computing for letting me do this talk in a different iteration before coming here. It actually had no narrative arc at all, and this is almost entirely about characters, an arc on how an epic journey is going to get you to your end destination of scientific discovery with Python, and how we can do a better together story. So, my name's Dawn Wages. I am the outgoing chair of the Python Software Foundation. If you have questions at the end, hopefully I go with enough time so you can give questions. Please feel free to ask me questions about the PSF. We have ongoing elections going on right now. I will ask you to get your phone out if you can, because there will be 2 QR codes that I would love for you to action. I also am a Python engineer, and I have been for going on a little bit over a decade. I also organize Python events, and I've been doing it as long as I've been learning Python. And I also contribute to the Wagtail CMS core team. And the other things we talked about, I lead a team at Anaconda for developer and community relations. So, if you could all take out your phones, I see you doing it. Yes, great audience, yeah. So there are 2 CTAs, main CTAs in this event. The first of which is I would love for everyone in this audience to become a Python Software Foundation member. There are 2 different ways to become a Python Software Foundation member. One is you can be a contributing member, which means that you give 5 hours on average a month or more contributing to an open source project or contributing to an open source community in Python. If you do that, it is self-nomination. You get to attest that yourself. No one's really going to follow up on you to make sure you're doing it. It is honor system, but please give back to the community, and you can also be a Python Software Foundation member. And then the second way is you can also be a sustaining member, which means there is a sliding scale membership, and you can pay to be a member of the Python Software Foundation with as little as $25 US. The other CTA is taking the Python packaging survey. This is a labor of love of mine. It's been years and we've had trouble getting off the ground a Python packaging survey. There's the JetBrains survey that is general Python ecosystem. This one's specifically on Python packaging. If you've ever pip installed, if you've ever conda installed, if you've ever cloned and built a Docker container and with an automation script and your Python packages were already in there and you didn't have to touch it, you're still welcome to take this survey. We'd love to know how people are using Python and how they're interacting with their packages in the ecosystem. We currently have 16,000 respondents, which is really big deal. The survey closes at the end of December, and then there's going to be an open data set in early 2026 with all of the responses available. So your responses could be included in that data set. And it takes usually on average like 10 to 15 minutes to complete. Perfect. All right, so this is going to be our epic journey. We're going to start with why the scientific Python community and ecosystem is so treacherous to maintain. It is something that's widely known across the ecosystem that scientific Python, and Python in particular, has environments that are kind of hairy and have some rough edges. When it works, but when it doesn't, it's really hard to navigate how to rectify, and sometimes you just want to blow up the environment and start over. Why is that? This discovery, the presentation through our scientific discovery, it always starts with a spark. In this journey, we'll start to understand why the Python ecosystem is so treacherous. And I posit today that there's two reasons for this. One, there's the evolving nature of software, and it happens across software, not just in Python. And we're in a critical inflection in the software development ecosystem because there's an incredible investment in making the development process easier for us. This is from the soaring success of VS Code. I mean, we probably have some Emacs and some Vim users out here, but IDEs are really the centerfold of how people are interacting with their code these days. And also the more recent advancement of AI assistants, making it even more efficient for us to engage in what we do. And the second is because you can do so much with Python. So in the early 2000s, with the proliferation of Python across many different subject matter expertise, you saw because of the way that Python provides you a way to interact and build with a level of abstraction away from the machine, you're able to build faster and more performantly, performant in a different way. It's not the fastest code in language, but it is more performant to build something quickly, and we're empowering users to build faster. That also means that there is different and disparate directions that the community can go to build one thing, and it makes managing those competing dependencies and environment sometimes more difficult. So it provides an immense amount of good and also allows for a diverse group of developers to create their very specific scenarios. We also want to go into, I would love a raise of hands. This is first of interaction part. Who's heard of the Python documentary? Ooh, yay, good. Who's watched the Python documentary? Okay, good number of you. So we're going to do a little clip of the Python documentary right now about how the first Python pre-version 1.0 was distributed.
The release, which turned out to be an incredible pain because Usenet was the only thing we had to release it.
Usenet was a network of, you could say, bulletin boards. People would write messages, they would get distributed over the world, and then there were the groups for all the different computer languages.
Usenet had a very strict limit on the size of a single post. First, put your entire source tree in a tarball. Then compress it. Then you have to do another step where you turn the binary data into ASCII encoding. So you have this huge file with gobbledygook, but it's at least printable gobbledygook. And then you apply another tool that snips it into pieces. Then there is a script where if you have downloaded all 21 parts, you can undo all those operations in reverse. That was what people put up with. So we did all the work on our side, and plenty of people did all the work on their side to unpack this, because I had apparently written a very good teaser about what this was.
And that's a little bit of the, let's put this back into presentation mode. Perfect. All right, we're back. Okay, we're back. Perfect. So that's a little excerpt of the documentary, which I really enjoyed watching. Hopefully that's enough to get the rest of you to want to watch the rest of the documentary too. And it's all on YouTube. Also, we're going to dive into what the ecosystem is doing currently to address it. So from really difficult developer experiences like we just saw, all the way to what we're going through now. We're iterating on a better developer experience every day, but there's much more to do. And then where do you fit in? A scientific Python fellow, how can you advance this? So in the grand scheme of this metaphor, we're going to get our supplies, we're going to cast our first spells, we're going to gather companions and address some of the trials and tribulations of the Python ecosystem. We'll form a fellowship along the way, and then we'll scale our quests. We'll give you some extra activities that you're going to do to continue this advancement and take record of our exploration. So you'll need a language distribution. There's many different ways that you can get your Python. Most people are more familiar with CPython. That is the default distribution that's done by the Python Steering Council. There's a language interpreter, package manager, development environment. You'll also want your version control. And if you're doing exploration with data, you'll want your data input and your pipeline for ETL. And then your specific domain is going to determine how your exploratory toolkit or your analysis engine is going to work. So we stumble upon a guide and a shopkeeper of sorts, and in their own right is experienced with all these very difficult tools to help us on our journey. Your IDE is your interactive development environment, will transport you to another environment and keep track of your variables of that universe and connect symbols across your files into other portals. I recommend a health check of sorts. Tools to provide health checks on your code are invaluable. For example, Conda Forge and Mamba have environment health checks. You can also consider hypothesis testing, data alerts on your pipeline to identify data drift, or data quality experiments, and keep tracking of those. And this may look like a simple ball of twine, but it is what holds your code together. From your development environment to your staging and production scenarios, Twine, the tool that is under GitHub under the hood, keeps your CI/CD moving from one environment to the other. And don't forget code formatters, linters, and style checkers. Organize your imports in security-focused linting like Bandit. Your spellbook or your documentation starts with writing spells so that you can recite them truthfully every time you need them to sit down and embark upon your own journey. But soon you'll expand that spellbook to be helpful for others. Share it freely and reduce the barriers for your fellow journeymen, and people across all levels will have the same reach that you do. And think of this like a time machine of sorts. You have mysticism, but beyond what you know. Specifically in scientific computing and scripting in Python, it's easy to jump into code without justifying why you should include version control. Think of it like your time machine. And the magic of data. Don't forget your data is gold. So when we're casting our first spells, another interactive portion, I'm going to ask you all to raise your hand. As you're starting your projects, who in this audience is using languages other than Python in their Python projects? Okay, I see a number of hands up. Are you able to, or do you typically anticipate the dependency considerations before you start? Or are you stumbling upon the dependencies and solving it as you get to it? So who's considering it before they even start the dependencies? Who stumbles upon the dependency contradictions and then fixes it as they go? Okay, more hands there. What about sharing environments with your peers? Are you predicting or expecting to share environments with your peers? Hands? Okay, good number of people are doing that. And what about tools that use project-based approaches like Pippin, Pixie, UV, Poetry? Hands? Okay, good number of people doing that as well. Cool. So this is like a common journey that you'll have in your data science and scientific computing process. You'll want to start with identifying your problem and your scope, and then get deeper into your data understanding, many times cleaning and normalizing and wrangling your data. You'll model your data when you have data science variations in scientific computing. And then you'll evaluate those models, and then check back with your production results. And here we met a friend with deep knowledge, driven by many years of pursuit, wise in many years, seemingly magnanimous, but it's their desire to understand the universe that makes them a great companion, and they're well-versed in the new and the old magic. They hear about your journey and they're immediately interested in helping. There's so many different ways people use Python, and there's a huge ecosystem with hundreds of thousands of packages available in open source to expedite your innovation. So you're able to leverage these packages for your accomplishments, speeding up the time to finish your task and pushing away from your desk. The first generation focused on integration with Python, Python's ease of use with the performance of compiled languages. Roughly from the mid-1990s to the early 2000s, tools like F2Py, which would be Fortran to Python, Swig, and later CPython really fit that bill. There was an emphasis on array-centric computing, introducing n-dimensional arrays that addressed Python's native list limitations and numerical data-enabled mathematical operations that are on entire arrays without explicit loops. So these free tools that were alternative to expensive proprietary tools like MATLAB, for example. And this is all within the academic and research origins. These are developed by scientists for scientists, and that signaled a big shift in the Python ecosystem. And by the end of this first generation, we see a movement into some of this new magic. The most newly adopted and widely appreciated packages in 2025, Polars is one of the rising stars that hit version 1.0 and is rapidly gaining adoption and potential Pandas replacement. It's lightning fast, a data frame library that offers significant performance improvements. Performance, particularly like Polars and DuckDB, are in a league of their own, being in an order of magnitude faster than Dask and PySpark. There are streaming engines that can seem to be 3 to 7 times faster than Polar's in-memory engine. And then there's also a huge wave with GPU accelerations. So for example, I've been playing with the NVIDIA Rapids library, which has been really exciting. And that accesses your GPU, whether remote or cloud, and provides up to 13 times performance improvements inside the Rapids Accelerator Polar's GPU engine. Another approach has also been with ecosystem integration. So for example, Polars works with major packages, including scikit-learn and plotting libraries through Narwhal's compatibility layer. There's also high performance data manipulation in Python. So all of these new features have led to this new magic of sort that's accelerating where we're going. We're seeing some changes with a performance-first approach. There's also a zero-code change philosophy. The most successful new packages of 2025 focus on providing performance improvements with minimal code changes. That would include the Rapids library. That's really exciting. Auto ML and democratization. So automated machine learning tools are becoming more sophisticated, and they're making advanced analytics access to non-experts. So we talked about our scientific companion. We have a new companion that we've met ready for this adventure, showing their fortitude. They're bringing in software competencies. This includes numerical accuracy, testing, being thoughtful on resource optimization, creating dry code. For those who may not be familiar with dry, that's when you don't repeat yourself in your code. So that's levels of abstraction and areas of ownership and expertise of your code, division of responsibilities of your code. Also, platform independence, so can it run on one machine versus another. And maintainability, which includes code quality, dependency management, your CI/CD pipeline, and your documentation. Some of the key insights is that scientific computing serves these dual purposes. It must produce correct scientific results, and it must be maintainable as a software system. So this dual requirement makes these principles especially important in the scientific computing ecosystem. I do have a call out at the bottom. Who of this audience, I'd love a raise of hands, who's familiar with PyOpenSci? Okay, great, a few of y'all. So hopefully I am introducing even more. So if you are in a scientific computing background and may or may not have experience with Python packaging, for example, this is an organization led by Leo Wasser, and they're a really fantastic group. They have tons of trainings, and they bring in experts all over the ecosystem to help you with your Python packaging, specifically in a scientific computing context. So let's dive into some of the trials and tribulations that we may find in our scary ecosystem that can be Python. Python support is a lot to learn, especially in scientific computing when your first domain may not be computing. Python's considered a glue language. So for example, there's a lot of people who call Python the second best language for everything. That would mean that maybe it's not the fastest language, but because it can do a lot of different things, it's very flexible, and it is a great middle layer language between your mini languages. It is definitely a popular language to glue your two languages together. Maybe you'll have a Java backend and a JavaScript front end, and you're running pipelines or integrations with your Python. It's used in a lot of different use cases. It's very flexible and extensible, and it can outsource a lot of the performance bottlenecks. We'll get into the next conversation. We'll get into the Python interpreter, and we'll talk about how the C API works in Python. And also, it's human-readable code. So I think that's a large part of even why the documentary, but a long time why people say that Python has gotten so much adoption, is because you can write your code, walk away, and not look at it for a year, come back to it, and still decipher what you were doing. So we have a side quest, and we have a special friend to help us through our side quest. We're learning the intricacies of the CPython interpreter. Who would consider themselves among this audience pretty familiar with how the CPython interpreter works? Raise a hand. Awesome, great. So it sounds like there's a good number of people who are coming along for the ride, and some people who may learn something from this little side quest. So there are many Python interpreters. There's Jython, which is written for Java and written in Java for Python. There's IronPython, which is written for .NET. There's PyPy, which is for just-in-time compiling of Python. It directly executes the code rather than needing a separate compilation layer. So that is why Python is directly as this. So either through hitting a play button in your editor, or Shift-Enter, or Python main, your CLI. There may be other ways that you can execute your Python. We have this friend whom we met along the way who can help us break down this process. Python is an interpreted language, so not all languages are considered interpreted. Some are compiled, and that means the program that you run is delivered as source code, and you can just run the source code. It'll start out with your Python file by the Python interpreter without any physical compilation. This is human-readable code. This is Python performing the lexical evaluations and then breaking it down into character tokens along with keywords, identifiers, and operators and literals. The tokens are now representing the shape of the code. Then it means, and then you go into your Python interpreter. The interpreter takes and executes each statement written in your source code. This will be line by line. The program gets compiled by the Python compiler and then checks for errors. And if the compiler finds an error, it will show the error in the console. And if there's no error, the source code is well formatted, then they'll be converted into bytecode. Bytecode is the low-level, unbiased representation of your source code. So the compilation to the bytecode is accomplished through the Python compiler and the Python bytecode compiler. The bytecode is then processed inside the Python virtual machine, and it is interpreted to give actual machine code. So in order for this portability of the source code to be valuable, this Python virtual machine now allows us things that happen at runtime, like dynamic typing and runtime introspection. This is also where the memory manager and the garbage collection lives. PEP 744 proposes a departure from the PEP 659, which is specializing with the adaptive interpreter, and this rewrites the bytecode instructions in place. So we're able to have more visibility into the profiling of the code. For example, we would be able to see what paths are being executed the most, or the memory layout of particular objects. And this is where the C API happens. So if we're offloading highly bottlenecks in our code, we're able to leverage the C API. This is dynamic loading of libraries in the standard OS method. So it'll load the entry point in its naming convention, and then it invokes the functionality where it's entirely responsible for what the modules set up and own. This is important when I talk more about optimizing with SPI or Numba. There'll be a little bit more about that later on in this presentation. But this is a nice extension point for when you have C, C++, Fortran, which makes it relatively easy to lean into performance improvements. And then you have your machine-readable code. The interpreter never produces any intermediate machine code, unlike a compiled programming language. And Python is easy for development environment because of the way that it shares the source code and interpret it dynamically. It'll allow you to write your code in all sorts of ways, have all different types of tedious and difficult dependencies, and Python's interpreter will just try its best to handle it. And then there are packaging complexities. We meet another friend who's going to help us with another tedious part of our main quest. These are deeply nuanced and scary complexities that they decide to offer their help and understanding. And Python packaging, combining utility into a reproducible and distributed version control way that allows for iterative improvements can work fine, or it could be incredibly difficult. Sometimes a package can be built differently based on the date. Or maybe bugs in GCC, which leads to loss of numerical precision based on import order. Or having the correct configuration script. For OpenSSL in particular, their configuration script is in Perl. Or maybe shared symbols across libraries that can delete references between versions silently. In GDAL requirements, this requires building Chromium, for example. Sometimes it'll build differently based on file system issues. Or it'll build differently across architectures. These are non-trivial considerations. For example, Pillow relies on an external C libraries like libjpeg, libpng, and zlib in FreeType. So that adds additional complexities to packaging Pillow, a commonly known kind of headache in the ecosystem. And this is not necessarily to denigrate any of these packages. These are how legacy concerns happen, and these are known concerns in the ecosystem, and how to address them are not easy. In GDAL, the Geospatial Data Abstraction Library, which is also notoriously difficult, it has complex geospatial toolkit with numerous dependencies and platform-specific quirks. So for example, GDAL supports dozens of geospatial formats, which all require different libraries. PROJ coordinates transformations, Geos, which is geometry operations, there's SQLite, Postgres, HDF5, NetCDF, and others. And it also imports different geospatial formats like GeoTIFF, shapefiles, PostGIS, etc. And PyTorch. These conversations are happening internally and out in the open for the community to participate. For example, matching PyTorch versions with your CUDA versions, PyTorch ships with specific CUDA versions baked in, and there's a huge download size with PyTorch, and there's also platform-specific wheels. PyTorch has strict compatibilities with requirements of NumPy and other core libraries, which conflict with other packages in your environment. And then we meet new friends, ones with domain expertise, are magical siblings which require you to make decisions before you can employ their services. You go down into domain expertise, or does your general purpose and build your own suit your needs. Well, we could start with general purpose tools like NumPy and SciPy, and then you can narrow in deeper into the funnel like broad scientific packages like Pandas or Matplotlib. We have domain-specific like BioPython, AstroPy, scikit-image, and then you'll also have maybe lab-specific packages that meet your specific needs in custom analysis. These are all tend to be problem-driven and designed and aligned to your data types and formats and incorporate domain nuance that allow for interdisciplinary collaboration. So our fellowship is forged. It's 2025, and scientific computing, the underpinning of AI, is finding its most salient applied use cases in this space. We have language and package distribution, your IDE choice, your framework architecture, environment standards and artifacts, and your build process and maintenance. The creators and the most active consumers have forged allegiances over the last 30-odd years, and some of these trends have emerged. So when it works, you may not notice when your Python distribution is not CPython, but there is a proliferation of other Python distributions. I'm most familiar with CPython and the Anaconda distribution and PyPy, the just-in-time Python distribution. But there's about a dozen more depending on your use case. People like development environments. We've talked about this a little bit before. It's gotten deeper in your expertise. And then people are also familiar and interested in tools that orchestrate your workflow. These are seen across the ecosystem, and there are too many environment standards and artifacts and a huge proliferation of tooling. I wanted to highlight 3 different PEPs for people who are not familiar. PEP is a Python enhancement proposal. So PEP 440, that's about version identification. And if you're interested, you can go deeper and to look into some of these PEPs. I think it's really interesting to follow the PEPs and where they go and the conversations around them, because you'll get deep expertise on why and the architectural decisions made by the proposers. There's also PEP 621, which is about project metadata, and then there's PEP 518, which is build system requirements. All of these are more recent or ongoing PEPs that are in discussion that people are really interested in to advance our Python ecosystem. And so we met our helpers. We started our journey. We met a friend who showed us the way and inspired us to believe what was possible, an epic journey. We met a shopkeeper who showed us the tools, and a sage friend with deep scientific knowledge of the old and new ways. We had a formidable warrior who equipped us with the software engineering principles of resilient code. And two deeply technical companions, one who helped us navigate the Python interpreter, and the other who helped us dodge the perils of complex packaging dependencies. And last but not least, our friends with deep domain knowledge. They know the dark arts of every form and can help us navigate our own domain nuance. But where do we scale? So the next step in your packaging journey is going to be making sure that you have observable, monitored, and logged code. You'll also want to have enhanced collaboration tools. So this would mean having reproducible research environments of sorts. Sometimes you can have tools that will allow you to work on code and jam together. And then also some tools that will create hashes or artifacts that will tell you if your code or environment have changed. You'll also be interested maybe in running on specialized architecture. So if you have high performance computing needs and you have compute intensive jobs, you might want to put that on a compute cluster somewhere on someone else's someone else's computer, or you might want to use your GPU and have CUDA enabled computations. I'm also really interested in the productize before production movement. This is the build it so it works for your specific need, and then do another round of refactoring to abstract away some of these dependencies, reduce repetition, and maybe pull away some code that can be open sourced and useful for others. I'm also interested in modular workflows, ones that can be cut up and you can document them individually, and hopefully, when done well, you can find drop-in replacements as you evolve. And then the best workflows, scaling your quest is always well-documented workflows. So that was scaling your quest with code. I want you to scale your quest with the PSF. So there is an opportunity to vote in this upcoming Python Software Foundation election. You can also join as a Python Software Foundation member, and then I'll talk a little bit more about the funding cycles in the PSF right now. So if you're not already involved or have not gotten your email, if you are a Python Software Foundation member already, you should have that email for OPA vote. Voting ends on September 16th, 2 p.m. UTC. But if you're not a Python Software Foundation member, and if you're just interested in seeing how the process happens from the beginning to the end for a full calendar year, you're in a great spot. You can sign up to be a PSF member today. Here's a QR code. This is where I got you originally to take out your phones. And you can be a PSF member. You can see the entire election cycle, and then you can follow along to see the board release minutes and voting procedures, and learn a little bit more about the PSF before you get a chance to vote in the 2027 elections. And last but not least, I wanted to talk about the funding in the Python community. So the PSF is known for giving hundreds of thousands of dollars every year to various communities across the world to help them with their Python events. It's something that we pride ourselves on. It's a main tenet of what the PSF does to help proliferate the language across the world. And we've paused our PSF program. There's a screen grab of the register talking about how the growth of the Python language has not led to the same growth in investments in the foundation. And so the pause has been twofold. It's been because we saw in the tea leaves, we've been paying attention, and we knew that the demand and the request from the ecosystem on us for more support has continued to grow. But we also saw that we've gotten into a more expensive conference environment. The main driver of funds for the PSF, which is PyCon, was not returning what it used to. And then we need the reciprocal investments from large companies. And we've seen similar movements across the ecosystem. Many PyCon conferences are experiencing the very same thing. So we're taking a pause. for a full calendar year. It is unprecedented, but we're really excited to get back to funding the ecosystem in a new and more sustainable way. And in the same vein, we have an end-of-year fundraiser. So please keep your eyes out for pyfound.blogspot.com. That's where you'll find our announcement for the end-of-year fundraiser. And if you have a company match, for example, you can fund the Python Software Foundation, or you can throw in the amount of a coffee every month in order to help fund the organization that proliferates Python across the world. Great job. We did it together. We unlocked the secrets of scientific Python. There's a few ways this analogy, almost done. There's a few ways this analogy falls short. So documentation exists, it's not dark magic. We iterate, it's not just one long journey. And you do not have to understand the entire ecosystem to be successful. Thank you so much to Riska Erlandsen, who provided the beautiful art that inspired this presentation. And here's another link to the Python packaging survey to take, and you can follow me on socials. Now I am all done.
Thank you, Dawn, for the amazing note. Thank you.
If you want to keep it up on the screen, I'm open to questions. I had open questions at a previous event, and I got grilled about the PSF funding cycles. I'm very happy to talk about the PSF. I'm happy to talk about Anaconda, developer relations, my journey in the ecosystem, scientific computing, any and all of these things. Any questions? I got one in the front. There's one right there, if you want to, or I can also repeat it for the audience. Awesome.
What is the minimum age for becoming a PSF member?
There is no minimum age for becoming a PSF member.
Anyone can become.
Anyone can become. Great question. Some like to know what the PSF does. Some wants to know what it's like being the chair of the PSF. Some have asked me why I'm not going to be the chair of the PSF in the next coming election, why I didn't run again.
Hello.
Oh.
Yeah.
Yeah, okay, got one.
We pretty much talked about packaging.
Yes.
So pip was part of Python, right? We get that as we install the Python.
Yes.
And now we have many things, UV,
Yeah.
poetry. Are we having any PEP proposal to include any of these tools into Python?
No. So it wouldn't be to include any of the tools. So there is PEP 772, which is the Python Packaging Council. So originally, the Python Steering Council, which is the organization that manages all of the PEPs and that will decide what exists outside of Python and what will bring brought into Python, there was one person who handled all of the packaging needs that handled PEPs. It was just not enough bandwidth. So what they did was they elected to spread it out into, I believe, 5 people who will exist on the Packaging Council, and they will decide any packaging standards. Right now, what I know is on their docket, but they have a list of intricacies, is a standard packaging format.
Yeah. Back then we had easy install. Then we have.
Yeah, I don't think they're going to bring in any of the existing tools. There is the PyPA, which supports some of the tools, like pipenv and maybe poetry and some others. Yeah. So, yeah, I don't believe they're going to be bringing in any of those tools into the Python ecosystem.
Thank you.
Yeah.
Yeah, hey. So I recently heard of this a new organization that formed called the Python Asia organization.
Yeah.
Is it separate from the PSF? What's the relation here?
They're separate from the PSF. So the PSF is a North American or it's a U.S. nonprofit. that is, its creed is its mission to support Python everywhere. So it is within our boundaries to support externally, but we are a US nonprofit, and so we're governed by those rules. And so there's Python Brazil as well, and EuroPython, the EuroPython Society, for example. Those are all considered sister organizations, like Python Asia, which is exciting. Yay, Python Asia. So that's good. Yeah, not the PSF.
So how does the dynamic work? Like, do they work with each other? Like, is there a structure there, or?
There's a lot of people who volunteer for the Python Software Foundation who also volunteer for Python Asia, but they are two separate groups, and the interaction is completely dependent upon the organizers, and there's no formal interaction right now. We just leverage each other's resources, and we're friends in the ecosystem, and we share ideas.
Yeah, I see. Okay.
Yeah.
Thank you.
Hey Don, good evening.
Hi.
First of all, a great session. Thank you for that. So my question is a little bit irrelevant to this.
Sure.
So it basically, I am working in Golang as well as Python.
Okay.
So we have seen a huge difference between how much Python can do and how much Golang can do in terms of concurrency. So the point is that are we doing something to improve that in the upcoming versions of Python, or how are we going to do, how do you optimize it, to get better performance out of Python?
Yeah. So I got good news and bad news on that one. So there was a team that was spearheaded by Guido van Rossum at Microsoft called the Faster C Python team, that just came to a close this year. A lot of their performance improvements, or some of their performance improvements, will be made it into 3.11, 3.12, and 3.13. We'll also see some of those in 3.14. That includes garbage collection, for example. I have a whole blog post on the other 4 that I think are really cool, but they're all very performance improvement heavy. Where the rest of the performance improvements are going to go, we're not sure, but there's definitely PEPs to facilitate this. People are excited about the JIT. People are really excited about sub-interpreters. Also, free-threaded Python, people are really excited about that. All provide some performance improvements.
Just to follow up,
Sure.
so I mean, we are all here because we love Python. So any chance we should be worried about, Python becoming a threatened sort of a language, just like the old languages went away, something like that?
That's an interesting question. I'm of the mind that we should always remain vigilant on where mindshare could go outside of Python. I think there's a strategic advantage, because I've invested so much of my time into Python. There is a strategic advantage to being careful and thoughtful and wanting to continue to make Python the best language there is. But also, I would love to challenge that question back a bit, and my own predisposition for wanting to keep Python great, and say that whatever comes next, if there is something that comes next, a better iteration, is hopefully comes of the vein of open source and innovation, and puts us in a place, all of us in a place, to pivot in a new direction and do more. So I love open source. Python, just because I love Python doesn't mean I necessarily hate TypeScript, for example. And so if we do it in open source, and if we do it in the spirit of collaboration, I'm really excited for whatever comes next. But I do love Python, and I want to keep it great, so it's fair. I'm not particularly worried. I think that we absolutely have the mind share right now, and it only looks like we're going to keep going up. But I think the next wave is going to be making sure that Python is optimized for the browser. So I'm super excited for WebAssembly being a platform for Python.
Great. Thank you.
Yeah.
Thank you so much.
Any more? Oh, I see another one. Hi.
Hi. I just have one.
Okay.
one,
Last question, or we have to be done? Okay, I'm so sorry. Let's go find each other in the hallway, and I'm happy to chat. Okay. All right. Thanks, everyone.
Thank you, Dawn.